Thank you for joining this lesson. We're going to discuss a mathematics topic, that is angle properties of a circle together with chords and tangents. Therefore, we are told in this question number 21, thank you so much for joining this lesson. We're going to discuss angle properties of circles together with chords and tangents. Therefore, remember to subscribe to this channel and to also share the link with friends. Let me focus on the question which has been provided here. We are told in the figure below, PQRS is a cyclic quadrilateral. So PQRS cyclic quadrilateral, that is a quadrilateral in which case the four vertices are touching the circumference of the circle. Given that PX is a tangent at P and O is the center of the circle. Again, we are given that PQ equals to QR, and we are also given that RQX is a straight line with angle RPQ equal to 50 as shown on the diagram. Again, angle TPS equals to 25 degrees as also shown in the diagram. Then the length of PQX equals to 18. PX that is equals to 18 centimeters. Giving reasons in each case, we are told to find. Giving reasons in each case, we are told to find. The first thing to be found is the angle PRS. Angle PRS equals to the angle at this point. Sorry, it's given PSR. PSR, the angle at this point. Remember, we have already been told that these two lengths are equal. This length and this one, they are equal. That means if this base angle at this point is 50, the angle at this point is also going to be 50. And PQR being a triangle, then the value of the angle at this point is going to be, remember 50 and 50 gives us 100. So the value of this one is going to be 80 degrees. Now considering PQRS as a cyclic quadrilateral, we usually say that the opposite angles in a cyclic quadrilateral are supplementary. In other words, they add up to 180. Therefore, we can say when we take 180 and we subtract 80 degrees, we are supposed to get 100 degrees. And this is the value of the angle at this point, because the angle at S is opposite to the angle at Q. So this is going to be 100 degrees, supposed to be supplementary. That is opposite angles. The reason, opposite angles, opposite angles, opposite angles in a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary. So that is why we are taking 180 to subtract the known angle so that we may know the remaining angle. In part 2, we are told to find angle PXQ. PXQ, the value of the small angle at this point. Remember now, RQX, as we've been told, is a straight line. So this means the angle at this point is going to be 100, because angles on a straight line should give us 180. Therefore, with 80, the remaining angle becomes 100. Something else we are supposed to understand is that we have a chord, PQ. This is a chord. Now, the chord is projecting an angle of 50 degrees in the alternate segment. And the same chord is leaving a certain angle with a tangent at this point. So this angle is also going to be 50. That angle is going to be 50, because we usually say the angle made by a chord and a tangent is equal to the angle made by the same chord in the alternate segment. Therefore, angle QPX equals to 50. Now that for triangle PQX, we are having 100 degrees and 50 degrees, then the remaining angle here is going to be 30 degrees. And the reason we are saying that is that because these are angles in a triangle. So when we take 180 and we subtract 100 degrees, the other angle is 50, we should get 30 degrees. These are angles in a triangle. Angles in a triangle. They should give us 180 degrees. We're also having another angle here to be calculated. Calculate angle POS. 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 So we can produce a line to O and another line to P. So that we call this one angle POS. Remember, applying the concept of angle in the alternate segment, we can say that PS is leaving an angle of 25 at this point. That means the angle produced on the other side is also going to be 25. The angle in the alternate segment, it's going to be 25 because when a chord leaves an angle with a tangent, the same chord subtends an equal angle in the alternate segment. Therefore, SRP is also 25. Now we can say from the form to angle properties of circles, we can say the angle at the center should be double the angle at the circumference. So 25 times 2, because the chord PS produces 25 at the circumference, and the PS is the one produces an angle at the center. Therefore, we can say the angle is going to be 2 multiplied by 25. This is 50 degrees. Angle at the center is twice the angle at the circumference. At the center is twice the angle at the circumference, as long as the two have been subtended by the same chord. As long as the two have been subtended by the same chord. Now we are having a part B, which is dealing with the length. Calculate correct to 1 decimal place the length the length not px but rx, the length rx, the length rx. So allow me apply what we call solution of triangles, and so that I may be conversant with the diagram, let me use the space up here. So we can apply solution of triangles, and we use triangle PRX, in which case I'll say, applying what we call the sine rule, when we take the length which is opposite to R, we call it length R, out of the sine of the angle at R, we are supposed to get the same as when we take the length which is opposite to P, small letter p, divide by sine of the angle at P. So this means when we take R, that is the angle opposite to point R, the line, that is 18, out of the sine of 50, which is the angle at R. This is supposed to be P, the unknown length, out of the sine of the angle at P, which is 100. When we combine the two 50s, we get 100. So we can get the length P by taking 18 sine 100 out of sine 50. So using my calculator, I can get this length. 18, the sine of 100, divided by the sine of 50. This is going to be exactly 23.14. 23.14. 0.14, but we have been told to 1 decimal place. So 0.1 centimeters, 23.1 centimeters. That is the length Rx, the whole of that length. Again, we are told to find the radius of the circle, the radius of the circle. So for us to find the radius of the circle, we are going to apply again solution of triangles. So the radius of the circle, remember this is 18. We can even get the lengths at this point. And we can say the length, this one being 23.1, we can say that when we take the outer length here, qx, we can call it x, then there is a remaining length here inside. Then we relate it together with the tangent px. So we will say 18 squared is the same as 18 squared is the same as when we take the portion which is outside x and we multiply it with the total length, which is 23.1, the outer length times the total length, then they are the same. They are the same. Therefore, we can get x. Can get x. So when I take 18 squared using my calculator, and I get 18 squared using my calculator, 18 squared, then I divide it by 23.1, I'm going to get x as 14.03 centimeters. Now, when x is 14.0, then it means length RQ, which is equivalent to PQ, is going to be, now I take 23.1 minus the 14. This is going to be 9.07. 9.07. Therefore, the length here is going to be 9.07 centimeters, while the outer length is 14.03. So that the total becomes 23.1. Now, with this length known, we can again apply what we call solution of triangles and say, in case we take twice the radius of the circle, we're going to get the sine rule, which can be given by the angle, which is 9, or the length, 9.07, out of the sine of the opposite angle, which is 50. So the angle opposite to that is 50. So twice the radius can be given by, when this one is divided by sine 50. So that, because this is twice r, now to get r, I divide by 2. This is going to be 5.9 centimeters to 1 decimal place.